All right, welcome back. And now what we're going to do is we're going to talk about what do we say when a matrix does not have an inverse, and how do we know when it does or does not have an inverse? And so in this case here, we have it right here. Okay, it says if a matrix A is reducible. What we mean by reducible is when we use those elementary row operations, we're reducing the system, the matrix, right? So if a matrix A is reducible to a row reducible matrix with one or more rows of zeros, right? We've seen that before. The matrix then cannot be written in the form of the identity on the left with a matrix on the right here of the vertical line. Okay? Because if you have a row of zeros here, right? If you have a row of zeros anywhere in this matrix here, then you can't put it in the form of the identity. You just can't, right? So then what happens? Therefore, the matrix does not have an inverse. So if you ever get a row of zeros, then you know to stop, because the matrix will not have an inverse. Okay? And basically what we say is that matrix is singular. We call it a singular matrix. Now, a matrix that does have an inverse is said to be invertible or non-singular. So we're going to start using the term singular versus non-singular. So singular matrices do not have an inverse, where non-singular matrices do, and we also can call those matrices invertible. Okay? And that's it.